In Chapter 16, we will discuss solid and hazardous waste. Let's take a look at the core case study, and let's talk about for a few minutes the traditional approach to how waste has been dealt with, which is a cradle-to-grave design, where the life cycle of a product begins when it is manufactured, that's cradle, to when it is discarded, and that's grave. A new design is a cradle-to-cradle design, where products are part of a continuous cycle. Take a look at figure 16.1. It shows you this continual cycle, where degradable parts will become biological nutrients, and reused parts are considered technical nutrients. So how can we make the transition to a sustainable, low-waste economy? Many scientists believe that this cradle-to-cradle design will help us move to that more sustainable, low-waste economy. What environmental problems are related to solid and hazardous waste? Well, solid waste contributes to pollution when valuable materials are not recycled or reused. Hazardous waste not only contributes to pollution, but also causes natural capital degradation, health problems, and premature deaths. We throw away huge amounts of useful things. Living in a throwaway society violates all the principles of sustainability. We could live more sustainably by viewing solid waste and pollution as potentially useful and economically valuable materials. So how can industrial and municipal solid waste be reused and recycled? And can products be designed to curb waste? Hazardous waste is a serious and growing problem. Waste can be classified as toxic, and that is discarded materials or substances that are poisonous, chemically reactive, corrosive, or flammable. Industrial solvents, hospital medical waste, car batteries, household pesticides, dry cell batteries, ash and sludge from incinerators and industry are all considered toxic waste. Radioactive waste comes from nuclear power plants, and it must be stored for 10,000 to maybe even 240,000 years. Currently, there's no known way to safely store radioactive waste. How should we deal with solid waste? Well, the best way to deal with solid waste is prevention. Do not use it to start with, if possible. Existing waste should be reused, recycled, or disposed of safely. Let's go over a few important terms. Waste management is controlling waste in ways that reduce environmental harm, and that may mean burying, burning, or shipping it to another location. Waste reduction is producing less or reusing, recycling, and composting existing waste. Integrated waste management is a strategy for waste disposal and reduction. Take a look at figure 16.5. Look how raw materials become solid and hazardous waste that are generated during the manufacturing process, and think about how they are managed. Then also think about waste that are generated by households and businesses. And again, look at how those wastes can be managed. Let's talk about the 4 R's of waste reduction. First of all, just refuse, don't use it. Or reduce, use less of it. Reuse means to use it over and over. Or recycle means to convert used resources to useful items or byproducts that are made from recycled materials. And don't forget about composting, using bacteria to treat biodegradable waste. Take a look at the figure on your screen. It demonstrates 40 ways to reduce waste and make positive purchase decisions in the home. Let's take a closer look at this. There are 6 strategies to reduce resource use, waste, and pollution. First, we can change industrial processes to eliminate and reduce the use of harmful chemicals. Second, we can redesign manufacturing processes and products to use less material and energy. Third, we can develop products that are easy to repair, reuse, remanufacture, compost, or recycle. Fourth, we can eliminate or reduce unnecessary packaging. Fifth, we can use fee-per-bag waste collection systems. And sixth, we can pass laws. If we decrease our consumption of matter and energy resources by refusing and reducing resource use, By reusing and recycling what we actually use, we will reduce pollution, decrease natural capital degradation, and save money. Take a look at figure 16.8 and think about the things that you can do in terms of reusing. Recyclable workplace and household materials include things like paper products, glass, aluminum, steel, and some plastics. So let's take a look at the life cycle of new items. New items can be put through primary or closed loop recycling, and a great example of this is when you take an existing aluminum can and you recycle it to become a new aluminum can. Now there's also secondary recycling, where waste materials are converted to new and different products, and there are 3 steps to secondary recycling: material collection, a conversion to new products, and new commercial sales. Another form of recycling is composting, where bacteria are used to decompose yard trimmings, vegetable food scraps, and other biodegradable organic waste. There are benefits from this. It enriches nutrients in soil, it reduces erosion, it retains water, and it improves crop yields. In Canada and in European Union countries, many cities collect and compost 85% or more of their biodegradable waste in centralized facilities. Take a look at figure 16.10 and examine the trade-offs of recycling. The technologies for burning and burying our solid waste have advanced, but both still have disadvantages. Burning contributes to air and water pollution and the emission of greenhouse gases, and buried waste contribute to water pollution. Take a look at figure 16.12 and examine the pros and cons of burning solid waste. Let's talk about the 2 types of landfills. Sanitary landfills are those that are filled with solid waste and spread out in thin layers. They're compacted and covered daily with a fresh layer of clay or plastic foam. This keeps materials dry, it reduces leakage of contaminated water, it lessens fire risk, it decreases odors, and it limits accessibility from vermin. An open dump is a large field or pit where garbage is deposited and sometimes burned. These are rare in more developed countries, but China does still use open dumps and poorly regulated landfills. Take a look at figure 16.13. It illustrates a state-of-the-art sanitary landfill. So I think it's becoming clear that the best way to deal with hazardous waste is to prevent it. Existing waste should be reused, recycled, and converted to less hazardous materials, and then the remainder should be stored safely. There are different methods to detoxify hazardous waste. Physical methods include taking the hazardous waste and using charcoal or resin to filter it. Hazardous liquid waste can be distilled, and sometimes hazardous waste can be encapsulated and stored. Chemical methods of dealing with hazardous waste include converting it to less harmful or harmless chemicals. And finally, bioremediation is a method that uses bacteria or enzymes to destroy and convert toxic or hazardous substances. There are a couple of other innovative ways to detoxify hazardous waste. Phytoremedication involves natural and genetically engineered plants that absorb, filter, or remove contaminants from the soil and water. They're referred to as pollution sponges. Plasma gasification involves electrically produced high temperatures to vaporize trash in the absence of oxygen. This produces synthetic gaseous fuel and encapsulates toxics in glassy lumps of rock. To shift to a low waste economy, individuals and businesses will need to reduce resource use and to reuse and recycle both solid and hazardous waste at all levels: local, national, and global. Take a look at figure 16.20 and consider some of the things that you can do. The Basel Convention Treaty bans participating countries from shipping hazardous waste to or through countries without their permission. The Stockholm Convention on Persistent Organic Pollutants regulates 12 of the most widely used organic pollutants, and in 2014 it was strengthened to ban or phase out these chemicals. A ban on transferring hazardous waste from industrialized countries countries to less developed countries still awaits ratification by the United States. 179 other countries have already ratified this treaty. In 2000, the Swedish Parliament passed a law requiring industries to perform chemical risk assessment. The burden of proof to show safety is now with industry. Let me know if you have any questions.